Welcome to the second lecture in software testing. As I noted before, the objective of my lessons are to give you a general understanding in software testing and also to make it quick. For this lecture, I'm going to be addressing software lifecycle and static testing. Software life cycles that I will be addressing come in three different flavors. The first one is going to be the waterfall. Next, I'm going to be addressing the software life cycle incremental. And finally, I'll be talking about the iterative life cycle. To make this more understandable, I'm going to go ahead and base everything on an example. So let's get going. The waterfall. The example I'm going to be using is a software program that has three processes, and each process analyzes data from a different sensor. So we have process 1, 2, and 3, and sensor 1, 2, and 3. So in the software lifecycle waterfall, the first task is requirements definition. So let's go ahead and define our requirements for our example. So what we have here, we have requirements for process 1, and the requirement for that process is going to be to enable user to select the sensor 1, evaluate inputs from the sensor, and then display the results. Then we'll have a process 2, which the requirement for first process 2, which basically does the same thing except that it's based on sensor 2. And we finally will have a requirement for sensor 3, which are same as before, but all related to sensor 3. So once we're done with requirements and the requirements are set on stone, then we do the software design. Following the software design, we'll do the module coding, next module testing, followed by module integration, system testing, acceptance testing, and finally product delivered to customer. So in this project, we do everything serially, and if we don't complete one of the tasks, we cannot follow to the next one. Now, the tasks that I have here in this project, I just put some tasks together for this example, but there would be much more in a real project. But this is just to kind of give you an idea that you have requirements, then the functional software do something, then the system test, and finally we have the acceptance test, and everything is in series. And the thing to understand here is that the requirements upfront are set in stone. You cannot change it as you go, the requirement. So let's go to the next life cycle. The next software life cycle is going to be the incremental. In the incremental, we're going to first build the prototype 1. So let's see what's going to be involved in prototype 1, the requirements. So the defined requirements for prototype 1, we're going to have requirements for process 1, where we're same as before, we're going to enable user to select sensor 1, evaluate inputs from sensor 1, and finally display those results. Then we're going to have, in this life cycle, we're going to have the design per the software requirements, module coding, module testing, same as before, module integration, system test, and then we're going to have a customer review. And finally, we'll have a plan for the next prototype. Now, the thing that you have to realize, prototype 1 has only the requirements for process 1, and the coding, integration, testing has only done for process 1. And finally, we have a customer review, which is a prototype where he can only see how the system is going to behave for process 1. And then also, once we are done with this prototype, the final step is to plan for the next prototype. So let's build the second prototype and see what's inside that prototype. So on prototype 2, what we have is a requirement for process 2, where we have only requirements associated with sensor 2. We're going to have software designed for those requirements. Then we're going to, same as before, we're going to code, test each module, integrate. But then when we do the integration, we're going to integrate prototype 1 and prototype 2. So basically what we are doing is integrating the process 1 and process 2. Then we'll do a system test, and finally customer review. So when the customer is reviewing this, he's basically reviewing a product that has functionality associated with process 1 and process 2, which is sensor 1 and sensor 2. Then again, finally, the final step in prototype development of prototype 2 is to plan for the next prototype. So let's go ahead and build prototype 3, which in this case is going to be the final prototype. So we have requirements for prototype 3, which is going to be associated with process 3. Then we're going to design software. We're going to have software requirements for process 3. We're going to code those modules. We're going to test each of the modules. But now when we get into the integration portion, we're going to integrate the software for prototype 1, prototype 2, and prototype 3. So this integration is the integration of the whole product. Then we'll have a system test for the whole product. Then a customer review of what's going to turn out to be the final product. And then final product is delivered to customer. So what we are doing here is we have a set of, up front, we have a set of requirements. And those set of requirements, we've partitioned them into partition them for implementation into 3 prototypes. And at the end we integrate all those prototypes and we get to the final review. But understand that the requirements are known up front. We're not changing requirements as we go. Now we change requirements if somebody screwed up and didn't get the requirements correctly, but in general the idea is that we get the requirements, we partition those requirements into prototypes. So let's get going to the final life cycle that I'm going to be addressing here, and that's the iterative software life cycle. So in the iterative software life cycle, what I have is I have a release 1, and let's see what requirements would go into release 1. So in release 1, I have process 1, and same as before, we're going to enable the user to select sensor 1. Now this is where things change. We're going to evaluate inputs from a simulated sensor. So before we were using the actual sensor, and the process evaluated data from that sensor. In this case, we have a sensor that has been simulated. Now, why would we simulate the sensor? Well, maybe we don't know what sensor we are going to be using. We haven't bought the sensor. We're trying to figure out what the sensor should do or the timing of the sensor. So we have a simulated sensor. Next, our display. This is now something different. The display results are going to be what I call in command line. It's going to be a text. So you're not going to have a fancy display showing you what you have. You're just going to have a command line where you have some text that shows you what's going on. So that's going to be the requirement for process 1. Process 2, we're going to do the same thing but simulating sensor 2. And process 3 is going to be same as before, but we're going to simulate simulate sensor 3, and again, all those processes, all the output is going to be from a command line and text. Finally, we're going to do here, then again we have our design software per the requirements. We code the modules, we test each of the modules, we integrate modules, we have a system test. Now at this point we could bring the customer to review what we have, and basically he would see the input and output from a command line in text, and he would see what happens with the simulators. The sensor have been simulated, and he can agree that that pretty much represents the sensors they want. So the important thing is that once we're done with release 1, we're going to evaluate and make trade studies based on the result that we had from that release 1, and we're going to update the requirements. Now this is different than before. Before we knew our requirements. Here, as we go, we are learning and we're tweaking and we're modifying, adding, subtracting requirements. So then we go to release 2. Now in release 2, we're going to use what we learned on release 1. So let's look at our requirements. So in this case, we have a process 1 where we enable user to select the sensor as before, but now we're going to be using the actual sensors. We evaluate the inputs from the sensors. So we learn what sensors and how to evaluate them in release 1. Next, we're going to everything still in the command line. Now, before I go any further here, I would like to say that in release 1, I could have decided just to have the requirements for process 1 and don't have requirements for process 2 and process 3. It just happened to be that I decided I just want to do the whole thing. So that's why I used but the idea is you have in the iterative, you have the flexibility to add and subtract things. So let's keep going with the requirements for release 2. So we have process 2, and again, this time we same as before, but we use the real sensor. And then for process 3, again, we have the real sensor, but we're evaluating real sensor, but the output is in a command line in text. So we don't have really what we wanted for the output. Then we have the design of the software. We code it. We do we test each module. We integrate the modules, system test, and then we bring the customer to review. Now the customer can see that he can see the connections to the real sensors, and he can see that we are actually reading from the sensors correctly. Then once we're done with the release 2, we evaluate and trade and update the requirements. So everything we learn in this second release, we do trade studies and we update the requirements to reflect what we learned from release 2. And then we finally get to release 3. So in release 3, we're going to have requirements are going to be enable user to select sensor 1, evaluate inputs from sensor 1, and then display results in GUI. So what we have here for process 1 are the final requirements in our release 3. So then for process 2, we also have all the final requirements, incorporating what we've learned so far. In process 3, the same thing. Next, we do the software. We do a software design. We code the module. We test each module. We integrate all the modules. Now everything is based on the final requirement. We do a system test. We do an acceptance test, and then the final product gets delivered to customer. So again, here what we've done is we've iteratively we've changed the requirements and we've tweaked things around to get to the final product. Not like in the waterfall where we had everything one thing after another one. or the other process where we actually had we partitioned the requirements. In this case, as we go, we learn in the iterative. So anyhow, that's what I had planned for software lifecycle. So now let's get back to testing. So static testing. Now when I talk about static testing, you are going to understand why it is important to understand the upfront the life cycle of the software. So in static testing, we have the requirements definition. We start the project, we have requirements definition, software design, coding, module testing. Now, all the things in this light green are going to be the software engineer is going to have responsibility for static testing. Now, I put in an arrow here that says configuration management. What configuration management guarantees is that if there is any change of the requirements or anything changes in this, what I have 4 boxes, then everybody's going to find out. If the requirements are changed, that everybody's going to get notified that requirements are changed. And the reason is because you want to make sure that everybody is playing by the same sheet of music. Next, I added here the quality assurance. Quality assurance is going to guarantee that everybody is following the rules, nobody's breaking the rules. So here we have static testing. Now let's talk about dynamic testing. We have integration testing, system testing, acceptance testing, and product delivery. These 3 testing are going to be what I call dynamic testing. Now, in this portion, we also have the configuration management and quality assurance. So the purpose of this chart was to show you the universe of the static testing and the universe of the dynamic testing. And now, of course, this is I already talked about the life cycle. So wherever these portions fit in the life cycle, that's where you're going to always have your static testing and your dynamic testing. Now, before I leave this chart, I want to talk about 2 last items. One is going to be verification. Verification has to do with system testing. Now, what are we doing when we verify? So when we do verification is we're making sure that the product was built by the requirements, meet the requirements. So if this requirement says to build a motorcycle, by God, we are verifying that the system that we built is a motorcycle. Okay? So make sure that the requirements were met. We built the product right. So this is the product was built right, built correctly. Now the next item I want to show is validation. Now I know that I built the product in accordance to these requirements, but then the question is, does this requirement reflects what the customer wanted? What I mean is, if a customer wanted a car, want us to build a car, does this requirement state to build a car or build a motorcycle? For example, if the customer wanted a car and the guys in marketing and whatnot did not understand what the customer wanted and he built a bicycle, then on the system test we're going to verify that the bicycle was built correctly. But then when we go to the acceptance test, that's when we're going to notice that what the customer wanted was a car, not a bicycle. So again, verification means we built the product correctly per our requirements. Validation means that we built the product that the customer wanted. So we we build the correct product for the customer. So let me repeat it one more time. Did we built the product correctly? Yes. We built the correct product? Yes or no. But the idea is that usually the product that we built correctly is the product that the customer wanted. So anyhow, I thought I would just spend some time on that little difference. So let's get back to now. I want to talk about unplanned work. So I'm heading towards static testing, but before we do static testing, let's talk a little bit about unplanned work. So the total work required that we have to do to complete our project is going to be equal to the work in progress plus work completed. So when the work in progress turns out to be 0, then we're done. The total work required is equal to the total work completed. We're done. However, before any of this work in progress can turn out to be, we can call it work completed, we have to make sure we have the software test here. So if something goes, you have an error, then the work in progress comes down to, it's called unplanned work, rework. And then once you've reworked it, then it goes back to work in progress. So if you have too many errors, you're going to spend a lot of time here, and not much is going to get into this bucket. So that's really bad news. So you want to have as little as possible rework. So look at this. Think about this way. You're a contractor, and you tell somebody to paint you subcontract the painting of your house to somebody else, and you give them the color. So they finish painting your house. You go inspect it, and you found that he painted the wrong color. Now this is going to require for you to, first place, we're going to have to buy paint again, and we're going to spend the time in repainting the whole thing. So you have to be aware that can be very painful. And the reason I'm talking about the house, because that's something that you can physically understand. Sometimes people don't understand when you have an error in software. That's a lot of energy is going to be spent and time to rework the whole thing. So some projects, they spend a lot of their time correcting stuff, a lot of time detecting. And that happens because they did not spend time in prevention. So what you want to do is you want to spend a lot of time in prevention, which is cheap, and as little time as possible in correcting and detecting and correcting. So reduction, rework through emphasis in prevention via static testing. Static testing is your prevention. So if you have static testing, then you are going to end up with a lot of prevention, which is cheap, and then some correction and some detection and correction, because you are always going to have some kind of a error. So let's look again at the universe of static testing. So static testing is going to be done on the required definition and during software design. So what I'm telling you here is that what I'm implying is that the software tester must be involved in the project up front. The first day of the project, when the project starts, you want the software engineer to be involved here. So now what do I mean by static testing? Static testing is where the software engineer is going to read the requirements, and he's going to decide whether or not they are testable. If requirements are not testable, that means that requirements are subjective, and if you cannot test them, that means that the person programming it should not be able to program. So let's go through some examples. Static testing verification requirements. So So I have non-verifiable requirements, and then I'm going to put next an example of how they become verifiable. The software shall provide accuracy sufficient to support terrain navigation. When somebody wrote the requirements, maybe they did not have that information, and they put that as a placeholder on the requirements. Well, the programmer, they looked at that requirement and they figure out, hey, the last time we did it this way, that should be the same, and now you end up in at the end of the project. That's when you found out that somebody made some assumptions. So your software tester up front says, no, I cannot test this. So then he forces the issue, and the requirement gets changed to the software shall provide accuracy of plus minus 20 feet vertical to support terrain navigation. Let's look at another requirement. The software shall provide response to pilot immediately. So again, the software engineer looks at that requirement. He decides that he cannot test it, so we change the software shall respond to pilot action in less than 40 seconds. Now, these are obvious examples, but you'll be so surprised to see how many times people write things that are not verifiable or testable, and the programmers go ahead and program them because they think they understand what you're trying to say. So anyhow, so now what I'm going to do is I'm just going to go through another set of examples so you can get an idea of the flavor of static testing, and basically is the software engineer up front trying to understand the system and trying to put his software test cases based on the requirements. So let's get going and read some of those. So static testing, non-testable requirements. So the software shall be robust. The software shall degrade gracefully under stress. The software shall be developed in accordance with modern programming practices. That should be, for example, in this case, the software shall be developed in accordance with modern programming practices in accordance with blah, blah, blah standards. So if you can put all the words you want, but at the end you need to have a standard, you need to have a paragraph and a section of that standard that person can go and can come out with test cases based on that standard. The software shall provide the necessary processing under all modes of operation. What can I say? The computer memory utilization shall be minimized to accommodate future growth. For example, you could say, when everything is done and all the program is completed, it should only use 30% of the memory, 70% of the memory should not be used, and that's going to be allocated for future growth. So I can put numbers to those things. And finally, the software shall be easy to use. You would say something under the software shall be easy to use in accordance with human factors, section, blah, blah, blah. So, sorry, so you want to make sure you have always standards and numbers associated. And if you have a standard, you must specify the section. You cannot say yes per this standard, because I've seen this and the standards are huge and the person programming doesn't know what to use. So he just grabs some part of that standard and say, well, I think he meant this. Well, no. If you call out the standard, you better call out the section and paragraph of that standard that they should be meeting. So anyhow, with this, we get to the end of my lecture. As I promised you I was going to talk about software lifecycle, which I did, and I also promised you that I would talk about static testing. So let's see. So in software lifecycle, we discussed the waterfall, the incremental, and finally iterative. And I think what we learned here, that this all has to do with requirements. In one case, we define the requirements up front, set them on concrete, and then we follow from there. In the second software lifecycle, incremental, we know our requirements up front, but we partition our requirements and we implement them in an incremental way. And finally, we talked about the iterative software lifecycle, where we we really don't know completely our requirements. We have some doubts, so then what we do is we iteratively we release a software and we learn from that, and at the end we have a solid set of requirements and we implement our product. Then I talked about verification, which means did we build the correct product per the requirements. And then I mentioned validation, which basically was, did we build what the customer wanted? Or that, another way to say it is, does the requirement meet what the customer was looking for? And finally, I talked about static testing, which is the review of the requirement by the software tester upfront. So I hope you've counted how many times I talked about requirements, how many times I said the word requirements, and how the requirements influence the life cycle, influence your verification, your validation, your static testing. So anyhow, I hope you've learned something from what I had to say, and I have these lectures in YouTube, so you can subscribe and you get notification when I release the next lecture. And the next lecture is going to deal with dynamic testing, so it should be fun. So anyhow, thank you very much for taking the time to listen, and hopefully you'll be able to enjoy my next lecture. Thank you very much. Bye bye.